So
screenshots.
I will go very quickly through the presentation because it's meant to be like quite short and so on. And there are lots of slides here, but I will just explain a little bit the concept of what I'm working on, and then try and show a little demo, which I have no clue if it will work because before it was working, but now I can share the screen properly. But anyway, so yeah, basically I'm a PhD student in the University of York and Goldsmiths here in London, and it's pretty cool because I can do research on games. So my topic of research is interactive machine learning for more expressive game interactions, right? Which is pretty cool because in VR, like right now the interactions can be pretty limited. Like the tracking is really good. You can move your hands, you can move your head. We have eye tracking, we have lip tracking, but still processing all this data can be very complicated. So let me see if I can go to my own screen and I can press this like that. Is it doing anything?
No.
What's
What
it
if I do
supposed
like
to do?
that? Ha!
Oh, yeah,
The
yeah. It's
virtual
changed.
keyboard
There we
works.
go.
Okay, I don't know if you can see me moving because I'm using the virtual keyboard and it's super weird. But anyway, this is me. I'm Carlos and these are my supervisors. That's not that important. But yeah, like we all know, like, game controls are the first thing that people encounter when they play games. They can affect the experience of the player. If a game has good controls, it will feel good to play. If it doesn't, then, it will be very frustrating and difficult to play. And in VR, there are lots of different motion controllers, different shapes. And, there's nothing, there doesn't seem to be a standard way of, integrating controls into your game. So yeah, like, there are lots of different shapes. So it's really hard to, like find a common pattern for all of these different kind of controllers. And there's going to be even more newer controllers coming up. So my focus right now is just on two-handed motion controls, which most VR systems seems to have. And even if they have like a bit of better ones or, more sophisticated, they still seem to be based on this idea of like two hands, that you can see the fingers maybe, or you can just see a hand, and depending on which buttons you press, your fingers do one thing or the other in VR. So that's my focus. So, I'm going to skip all these slides because I'm talking about different motion control schemes for games. We all know Job Simulator, like it's really cool, but interactions are very simple. You just throw things around, press big buttons with your hands. There's very little nuance. In Beat Saber, it's really good fun. If you guys haven't played, you need to. But again, the interactions here are super simple, right? You just slice your arms in a direction, and that's it. You don't do anything else. And when you have a bit more of a complex interaction, it's actually super hard to code. So the very popular archery examples, if you guys seen any of the open source scripts for doing archery, like in VRTK or any other framework that already includes archery, it's very complicated, right? There's a lot of things to position in your 3D model. There's a lot of like tweaking in your script to make it feel good. Skyrim, for instance, it released on VR, and then there are lots of mods that everyone is tweaking archery in a different way because it doesn't work really like extremely well. So yeah, it's very complicated and it's very time consuming to these kind of nuanced gestures. So basically, my solution to this problem, and I'm gonna skip to here, is to reuse some research in actually audio research. In audio research, this incredible woman over here, Rebecca Fibrink, she thought of using machine learning to create virtual instruments so that people could play new ways, like new instruments that doesn't exist really easily by letting musicians configure their instruments virtually using machine learning. Just, by providing examples of, I want to play this note by doing this gesture. And then, like computer learns by example, you say like this note here, this position of my hand is a high pitch note. This lower position of my hand here is a lower pitch note. And just by this example, the computer will learn really quickly, right? With machine learning. which is kind of similar to how keyboard games or controller games offer options to remap keys, right? When we think about it. So this paradigm of machine learning is very interesting. It's called interactive machine learning, and basically here the user interacts both with the data and with the model, right? I don't know how familiar are you guys with machine learning, but basically machine learning is a field of artificial intelligence research where we have algorithms, functions in programming that get some data and they learn patterns, right? By providing lots and lots of data, they learn slowly or very quickly, depending on the algorithm, different patterns, right? So if you show a lot of faces, to one of these algorithms, then it will eventually learn that, oh, this is a face. Oh, I didn't realize before. Um, and the interesting part of this paradigm is that here, the game designer or the game programmer or the, game audio designer or artist, it can interact with this technology very easily, right? That's the idea. And, you can tweak the data. You can say, oh, well, I don't like this gesture I'm performing, or I don't like this interaction I'm doing. I want to modify, I want to provide different examples so that the algorithm will learn. Or, oh, I don't like this algorithm. Let me change for this other algorithm in the list, see what happens. Um, so that's more or less the idea behind this. It's probably a bit abstract right now, everything I'm saying. So let me show you what we did. I'm going to skip this. And we did this tool, which is actually like really cool, and it's been the last year and a half of my life. InteractML, it's a visual scripting machine learning framework for Unity. It was originally funded by Google, so we got really lucky. We got money from them, and like they really liked the idea and so on. Unity also is very interested in it. Probably it won't go into the main Unity versions, but we are collaborating with them a little bit because they also have their machine learning framework, which has a very different aim than ours. But yeah, like InteractML, it's basically an interactive machine learning framework for games, and it's open sourced. You can go to the GitHub repo, inspect all the branches, all the scripts and everything, and yeah, you can program everything visually. So the barrier to use this tech should be very low, and it's completely free to use, right? Like it's funded by Google and currently it's funded by the EPSRC, by the UK government. So it's great. So yeah, I can show you probably a little demo of InteractML. I will stop the presentation here. We don't need more slides. So let's go here and let's see if you can see my Unity scene. All right, can you see these guys?
Yep.
Yeah.
Okay, cool. Yep. Ooh, nice, exciting. What am I doing in VR? Am I moving my hands?
Your hands are outstretched.
Yeah.
Oh, really?
Yep.
And if I do like that, can you see me now moving my hands properly?
Yeah, they're moving.
Okay, cool. Right, so maybe this part of here I can do not in VR. Let me see if I can do it in VR. What if I do like that? No, it doesn't work. If I do like that, that works, but I'm missing controls. Yeah, let me do this not in VR. All right, so I'm gonna remove my headset. Can you guys hear me?
Yeah, it just look like you have a broken.
Oh god, this is terrifying. It's happening.
Okay.
Oh my goodness.
Can I speak?
Yeah.
Yeah, I can hear you. Awesome. And probably my head is doing really weird things in VR.
Yep.
Anyway, so this is the interface for InteractML. I have here a few nodes, and I have a simple scene that I'm working on. It's like a really cute version of Venice, or that's what I intend to do. And I'm, trying a few things here. So in this scene, I prepared a little demo to show how can you control, for instance, the light of the scene with my hands in VR, right? Without writing any code and using machine learning, for instance, which is very simple. So in here, I have my game object, which is my left controller. And I am extracting the position of the left controller, and I want to input this into a machine learning system, basically. I have taught the machine some examples of how I want the light to behave. You know, like I basically taught when my hand is in this position, I want the light to be this way. When my hand is in this other position, I want the light to be in this other way, right? And then I train this model just by pressing a button, and I'm sending this value to a script. So let's see now if this is going to work, because it's a demo, it's real time, it's very experimental software. So let's see. Let me put this here. Can I click play, and will it break Unity? I'm scared.
The suspense.
Chun chun, chun chun, chun chun. Okay. Can you guys see anything?
Yep.
All right.
The there.
Okay, cool. Right, so it seems to be working, but I lost my reference to my game object. That's probably a bug. Yeah, here you are. Right controller, left controller. This is the one I want. Okay, so I will move my game object here. Yeah, sorry guys, this is a bug. And I will place it here. And is this getting the values properly? No, it's not. What if I break the connection? Aha, there we go. Right, so here I'm basically getting the values from my controller. You can see my controller on the screen, right?
Yep.
Yeah.
Cool. And you see the screen is very dark right now because the model is off, it's not running, the machine learning model. So basically what I'm doing is I'm sending this information from my controller to the machine learning system, right? And this machine learning system has two algorithms, one for classification and one for regression. So let me swap to classification here. Classification, it's basically an algorithm that lets you classify things into categories, right? So here I have two categories, on and off, right? The light is very, very dark, or the light is in a certain position, so I can illuminate the world. So I provided these examples here in this other node, right? And then I am sending these examples here together with the position of my hand, right? So what I'm gonna do is I'm gonna train the model on this data, and I'm going to run it, if Unity allows me to. I've never done a live stream of this, okay?
Oh.
Okay, but this is regression. So reset model, train model, run. There we go. That works as I want. Yeah. So this is a classification algorithm. So basically, when my controller is to the left, the light is dark. But if I move my controller to the right, it's on. Right? Very simple. This is classification, right? You can have a lot of classes. You could say like when your hand is like that and you do like that, the light turns on, or when you do this gesture, the light, I don't know, reacts in a specific way. You can show as many examples as you want. It's up to the game developer. And this algorithm will classify in one of these examples you taught it. It will not do anything that it doesn't know. But there is another algorithm that is a bit more fluid. So this other algorithm is called regression, right? And in regression, you actually can generate values that you didn't teach to the algorithm, right? So I'm going to swap the learning choice to regression. I'm going to reset my model. I'm going to train it. This is going to take a few seconds because right now I don't have multi-threaded implementation. That is just a few seconds. There you go. And now you will see that if I run my model, now, as I move my hand, I can control the light of the of the scene. So if I move my hand a lot to the right or to the left, then I am affecting the illumination based on two very simple examples. Like I only thought this way is off, this way is on, right? And it's generating lots of different values according to where I move my controller. And this is just controlling the light, right? It's a very, very simple example. But the idea is that you could pipe this into whatever you wanted. So it's really powerful. You could control sounds, you could control colors, you could control the behavior of agents in the world. You could control, like, I don't know, a branching tree dialogue depending on how you move. It's really powerful. So it's so powerful that we have no clue what we can do with this because the possibilities are almost infinite. So we are actually organizing a series of free workshops where we are teaching people about machine learning in games, and we are teaching them how to use this completely for free. It's paid by the UK government. And I have a flyer actually here. So I will open this PDF. So you can see, I will probably distribute this in the Discord later. So we have this study to create movement interactions with machine learning. And basically, we are looking for game developers that wants to learn about machine learning, and wants to do something small and interesting and different so that we can understand academically and scientifically what can be done with InteractML in games. And yeah, if you guys are interested, please let me know. You can grab me on Discord. You can grab me right now. You can ask questions, and that would be me. Probably I can show you the website. The website is called InteractML.com. And here you can get more information. You can go to the GitHub as well, download a GitHub, and that will go to our GitHub site. And you can try it out if you want as well. Probably if you try it out, you will see that it's having a lot of bugs right now. But let me know, and I can point you to a stable release, and you can play with it if you want. So yeah, guys, thank you so much.
Yay.
Thank you, Carlos.
Thank you. Oh,
Oh, wait, yeah. I forgot about that.
Click the wrong thing.
There you go. Clapping
Yay.
emoji. Wow.